Today we will be going over Chapter 1 in AP Physics C Mechanics, which is about measurement. So the first thing we really want to focus on, the first major topic in Chapter 1, is the idea of dimensional analysis. You may have covered this in your Chem Honors or Physics Honors class, but we will also go over this again in Chapter 1. The main part about dimensional analysis is to learn how to change units of time, length, mass, any units of measurement, and being able to convert between types of SI units and into the US system. The second major thing that we will be going over is the formula for density. Density may be a concept that you have approached before. The formula is rho, which kind of looks like a P, equals m over v. This corresponds to density equals mass over volume. Mass, in this case, will have the units of kilograms. Volume, in this instance, will have the unit of meters squared. So this will give density a unit system of kilograms per meters squared. Have to make a little correction here. Volume is actually meters cubed. So volume would be meters cubed, and the overall formula for density would be kilograms per meters cubed. The next major thing that I highly recommend that all students memorize are the prefixes for every single unit. So here we have a list of prefixes. On this side we have the major smaller prefixes, and on this side we have the major larger prefixes. You can see in the smaller prefixes we have 10 to the power of a negative power. This is a scientific notation form that is used to convey really small or really large numbers. On the other side we have the larger numbers with positive exponents for 10. The major prefixes you should know for the smaller numbers are deci, which is 10 to the power of negative 1, centi, which is 10 to the power of negative 2, milli, which is 10 to the power of negative 3, micro, 10 to the power of negative 6, giga, 10 to the power of negative 9, mega, 10 to the power of 6, and kilo, 10 to the power of 3. So the major ones here we want to highlight are kilo, milli, and centi. These will come up often throughout the chapter and in your practice problems as well. So looking at these prefixes, they can be applied to 3 types of measurement. These are the major types of measurement, although there are many other forms of measurement out there. But these measurements follow the SI unit system. You may also know this as the metric unit system. This is used by major companies, most educational institutions and most institutions in general around the world. So the measurement for length is meter. So this is the base measurement. Everything is based on this, and we can add prefixes to this to convey a larger form or a smaller form. This is used for length. The second form of measurement is time, which we use in seconds. Seconds is a little iffy in this scenario because we do not use larger prefixes on seconds. I mean, I'm pretty sure you've never heard a gigasecond before. Instead, we use minutes and hours and days. However, we do use the smaller prefixes, but you most likely will hear the term microsecond or nanosecond. So be sure to be familiar with these terms. The last term is mass, and the base unit for this is the kilogram, not the gram. The kilogram, taking the root word over here, kilo, says that it's 10 to the power of 3. 10 to the power of 3 is also 1,000. So that means there are 1,000 grams in 1 kilogram. It's important to note that mass is very different from weight. Weight equals to mass times the effects of gravity on it. So weight is the measurement that changes when you're on a different planet. When you're on the moon, your weight is different. When you're on the Earth, your weight is different. However, your mass will always remain the same. Thank you for watching, and next time we will be covering more sample problems in Chapter 1 that go over dimensional analysis, density formulas, and exploring more about prefixes. Thank you.